Q8808. What is a cause of generator brush arcing? A. Seating brushes with no 00 sandpaper. B. Carbon dust particles. C. Low spring tension. The correct answer is C. Generator brush arcing refers to the phenomenon where an electrical discharge or sparks occur between the brushes and the commutator of a generator. It can lead to increased wear, poor electrical contact, and potential damage to the commutator surface. Low spring tension is a common cause of brush arcing. The brushes in a generator are held against the commutator by springs. These springs provide the necessary force to ensure proper contact and maintain a consistent electrical connection. If the spring tension is too low, the brushes may not make firm contact with the commutator, resulting in poor electrical transfer and increased resistance. This increased resistance can cause arcing, as sparks or electrical discharges jump across the small gap between the brushes and the commutator. By ensuring that the spring tension is appropriately set and maintained within the manufacturer's recommended specifications, the brushes can maintain consistent contact with the commutator, minimizing arcing and promoting reliable electrical performance. Q8809. When operating two aircraft AC generators in parallel, what must be equal? A. Amperes and frequency. B. Frequency and voltage. C. Amperes and voltage. The correct answer is B. When operating multiple AC generators in parallel, it is essential to ensure that the frequency and voltage of the generated power are the same for all generators. This synchronization is crucial to maintain proper electrical system operation and prevent damage to connected electrical loads. Frequency synchronization ensures that the generators are producing electrical power at the same rate, which is typically 400 Hz in aircraft systems. If the frequency of the generators is not synchronized, it can lead to electrical interference, unstable operation, and potential damage to sensitive electrical equipment. Voltage synchronization ensures that the generators are delivering power at the same voltage level. If the voltages of the generators are not synchronized, it can result in voltage imbalances across the system, which can cause uneven power distribution, excessive currents, and potential damage to electrical components. By ensuring that the frequency and voltage of the generators are equal, the generators can be operated in parallel safely and effectively, providing a reliable and balanced power supply to the aircraft's electrical system. Q8810. What does the starting current of a series wound DC motor produce? A. High starting torque. B. Speed slightly higher when unloaded. C. Low starting torque. The correct answer is C. The high starting torque of a series wound DC motor is attributed to the fact that all of the current flowing through the armature also passes through the field winding. This series configuration allows for a significant amount of current to be directed to both the armature and the field winding simultaneously. As a result, the motor generates a substantial starting torque, making it suitable for applications that require a powerful initial rotational force. Q8811. Which motor would be most likely to have an armature brake? A. Starter motor. B. Landing light retraction motor. C. Inverter drive motor. The correct answer is B. An armature brake is a mechanism used to quickly stop the rotation of a motor's armature. It is typically employed in applications where it is necessary to halt the motor's movement rapidly and precisely. Among the given options, the landing light retraction motor is the most likely to have an armature brake. When retracting landing lights on an aircraft, it is important to ensure their swift and accurate retraction. An armature brake can be utilized in the landing light retraction motor to promptly stop the motor's rotation once the lights have been fully retracted. This feature allows for precise control and positioning of the landing lights. Q8812. What is the most common method used to overcome the effect of armature reaction in a DC generator? A. Interpoles. B. Shaded poles. C. Drum wound armatures in combination with a negatively connected series field. The correct answer is A. Armature reaction in a DC generator refers to the magnetic field distortion caused by the armature current flowing through the armature windings. This distortion can lead to various issues such as excessive sparking at the brushes, commutation problems, and uneven distribution of magnetic flux. Interpoles, also known as commutating poles, are small auxiliary poles placed in between the main field poles of a DC generator. These interpoles are connected in series with the armature and are designed to produce a magnetic field that opposes the armature reaction. The direction of the interpole's magnetic field is such that it neutralizes the magnetic effects of the armature reaction, resulting in improved commutation and reduced sparking. By using interpoles, the armature reaction in a DC generator can be mitigated, leading to smoother operation and better commutation. This method is widely employed in DC generators to overcome the adverse effects of armature reaction.